Okay guys, here's the intro for arithmetic progressions. Just a quick little intro. Basically, arithmetic progressions, or APs as we say, they're denoted, basically what they are is any sequence whose successive terms decrease or increase by the same amount is called an arithmetic progression, an AP. Successive terms. So what we mean by that is take a term in the arithmetic progression, then to go to the next term you'd add or take away a fixed constant, and then to go to the next term you'd add or take away a fixed constant. So you can see the general way that this is denoted. A is termed the first term, D is termed the common difference, and so you add D, one D to get A plus D the next term, then add another D and you'll get the next term, and so on and so forth, until basically you get to the nth term in the sequence. There's n terms in this sequence, so the sum of the first n terms is denoted by capital S subscript n, and basically there's n terms here. And you can see, because we're counting from 0, aren't we? There's no d's here to count. There's 1d, there's 2d, and then we go up to n minus 1d. So that's something to note, that the nth term in the sequence, because we started at a with no d's, it must be a plus n minus 1d's, mustn't it? Okay, so there's the general format and pattern or description and a generalized way for an arithmetic progression. There's a couple of formulas which are dealt with in the long clicks, the derivation of, that is, and here they are here. The last term is called the nth term, or the last term. First term is a, second term is a plus d, and the third term is a plus 2d. Notice that the number of d's is always one less, so the third term will have 2 d's in it, the second term will have 1d, the first term will have no d's at all in it, the nth term will have n minus 1d's, as we said. So there's a couple of formulae that we can use for the sum of the first n terms of an arithmetic progression that I've written down here. N over 2 brackets 2a plus n minus 1d. And you can see that there's an a here, if you separated the a's, and there's also an a plus n minus 1d. And if you replace that by L, then you can have the alternative form of the formula. So the n over 2 remains the same. One of those a's comes here, and the a plus n minus 1d, we can replace it by L. So for some problems, this one is more convenient to do, especially if you're given L explicitly, or can find it easily. And here, on other instances, this formula is used. This one is one we use most often, I would imagine, in practice. Okay, a couple of examples then of what we mean in concrete terms. 2 plus 5 plus 8 plus 11. Here the first term, a is 2. Yeah. The common difference is plus 3, because we're adding 3 to each subsequent term from the previous. And the number of terms, well, 1, 2, 3, 4 terms, so n is 4. Okay, good. And then the next term sequence, 3 minus 2 minus 7 minus 12 minus 17. There's 5 terms in this sequence, so n is 5. The first term is 3, and to go from 3 to minus 2 you take away 5, and then you take away 5 to get to the next one. Again and again, take away 5 again to get to the last term. So the common difference is minus 5. So we're adding on minus 5. So we always think of it in terms of addition in our mind's eye, or conceptually speaking. But it happens to be negative, so in effect we're taken away. Okay, so there's a common difference there for that second example. So if you want to have a look at the bookwork, it's on the long click of this section. But otherwise, all the best in the section. I hope you get on okay with these questions. Cheers!